Hello everyone, this is Daddy Question here today, and today I'm going to show you how to do inequalities. So I know equations, they're quite easy to master, just the simple rules, and yeah, there you go, algebraic expressions and equations done. So now we're gonna go on to inequalities, which is pretty similar to equations. So today we're gonna start off with a simple question. So we're gonna start with x plus 3 is greater than 5. Oh, this is really simple to solve because, as I said, it's very similar to equations in the sense that we can apply the same laws to get the answer. So in an equation, normally we'll minus 3 on both sides, right? So that's what we're gonna do now in this inequality. We are going to minus 3 on both sides. So we're gonna say x is gonna be greater than 2, okay? And that's, a pretty simple question. And we're going to move on to a harder example. Now let's do this inequality here. The question is that 2x minus 3 is less than 7. Okay, now similar to the last question, this is a two-step inequality. So what we do is we first get rid of this negative 3 here. So let's get rid of that. Let's add 3 on both sides. And if we add 3 on both sides, that negative 3 is going to cancel out with the 3 we add on, and therefore we'll be left with 2x. So that's going to be 2x is less than 10, okay? And then all we have to do is divide by 2 on both sides, which means that we have x is less than 5. Pretty simple, right? Now, there are a couple of rules that I want to explain to you with this next example. In this example, I'm going to explain to you an important concept in inequalities that is not present in equations. And this is one of the questions that we have to be very careful of. This says x over negative 3 is less than 5. Now, to solve this, right, normally in an equation, if it was x over negative 3 is equal to 5, this is just a really simple equation. All we have to do is we have to multiply by negative 3 on both sides, and that's just literally our answer. X is equal to negative 15. Yes, in equations we do this, and this is absolutely correct. But however, in inequalities, this is extremely different. Yes, we can multiply by negative 3 on both sides. We are allowed to. But however, there is a rule. In inequalities, if you multiply or divide by a negative number, you have to switch the symbol. For example, in this example here, when we multiply by negative 3, we get x is greater than negative 15. Now you're thinking, why is this true? Why do we have to switch symbol? Alright, so let's do a simple example. So let's just forget about x. Let's just do 2 is smaller than 3, right? Of course this is true. But when we multiply both sides by negative 1, let's just multiply both sides by negative 1, multiply by negative 1, we will actually get negative 2 is something compared to negative 3. As you can see, smaller than doesn't actually work because negative 2 is actually bigger than. So when we multiply or divide by a negative number, the sign has to switch. Alright, so I'm going to give you another example with the same concept. So this is another example to practice a negative sign switching principle. And so let's start off by, just doing a normal inequality, solving it. So the first step into solving it is to minus 8 from both sides. So let's take away 8 there, and let's take away 8 there. So we have negative 2x is smaller or equal to 3 over 5 minus 8. Now, when we divide by negative 2 on both sides, we have to switch the symbol, remember? So let's divide by negative 2 on both sides. We'll have x is greater or equal to. So less than or equal to will switch to greater than equal to, okay? And then we need to divide this all by negative 2, which is 3 on 5 minus 40 on 5. 8 is the same as 40 on 5. We do this so we can take away these fractions here. Divide by negative 2. Alright. And so the next step is just to simplify the right hand side here. Since we already have x on the left hand side, we don't need to do anything about it. X is perfectly fine there, and what we need to do is simplify the right hand side. So let's do that. When this gets subtracted, we have 37 over 5 over, negative 37 over 5 over negative 2. This is the same as x is greater or equal to 37 over 10, okay? 37 divided by 10, which is the same as 3.7, but in this case I want to leave it as improper fraction, but when we're graphing on a number line, probably changing it to a decimal would be easier. Alright, so now I'm going to teach you how to graph all of this on this number line here. Alright, so for beginners, graphing this may seem like, how do you graph x is greater than 2? Because if it was a normal, like x equals to 2, right? We just find 2, let's call this 1 perhaps, and let's call this 3. Okay, so all you need to do is just, graph it. Put a dot on 2 if it was x is equal to 2, right? This was just a dot on 2. But however, we're talking about x is greater than 2, so that's different. So how do we graph that? Well, first of all, there are some rules in drawing the number line. A number line, right? First, there must be at least 2 points in comparison. Here are 3. It's best to do 3 because when teachers see 3 points, it's easier to mark, it's easier to understand where the point actually is. So here I have 1, 2, and 3. And so that's pretty much the basics of drawing a number line, okay? It can be in any scale as long as the scale is the same, okay? Okay, so let's start by graphing x is greater than 2. How we do this is we get 2, as we can see. Here, 2. We draw an open circle over 2. Because x is greater than 2. So x doesn't actually include 2. That's why it's an open circle. I'll run through a closed circle later on, but for now we're doing open circle because x is greater than 2. And x is not in the set of values which are lower or equal to 2, so we can't include 2. And since x is greater than 2, all we need to do is draw an arrow going to the right of the number line. So it might be a bit faint here, but there is a green arrow pointing to the left. Okay, so some common mistakes to avoid is going up and across like this. Okay, it's not very good practice. It's best to do it on the line or very, very close to, very, very close to the line. You never ever go below the line. That's just wrong, okay? Depends where you are. Sometimes going above is allowed, but I like going on the line. It's just a common practice. It's so much easier. But there you go. This is x is greater than 2, this graph right here. Now let's move on to a different example, this time with a closed circle. Alright, so in this example, we have x is smaller or equal to 2. Now, as you can see here, the number line stays the same. It doesn't matter since we still have our 2 value here in the middle, which is, again, like I said, a good practice. So how do we graph this? Well, since x can now obtain the value of 2, we can add a closed circle onto 2. What this means, a closed circle means that x can have a value of 2. And an open circle means that x cannot have a value of 2. And so, as you can see here, x can be anything that is smaller than 2, right? Including 2 itself. That's why we have a closed circle here. And smaller than 2 is left, right? So what we want to do is we want to draw an arrow on the number line going left. I'm going to make it a little thicker so you guys can see. We'll have an arrow pointing left. We want to make this arrow, not too short, maybe like not that long. Probably a little bit longer, so it's easier for markers to see. And that just, makes it so much easier to mark. Let's move on to a different example. This time the number line is going to have a negative value. And so in negative values, you have to be a little bit careful. Alright, so in this question, we have x is greater or equal to negative 3. What we want to do to start off with is we want to put a value of negative 3 here, right in the middle. And then the 2 values surrounding it. Well, we know that going this way is increasing, right? And this way is decreasing, increasing and decreasing. So what is lower than negative 3? Well, you might be tempted to write, negative 2. But this is actually not the case, because -2 is actually greater than -3. So we have to be very careful of this, and instead we have to write -4, because -4 is lower than -3. And on the other side, we write -2. Now, the question asks you to graph x is greater or equal to -3. So let's do that. X is greater or equal to, sorry. So since we can include the value of -3, we can put a closed circle on top of -3. And then we also have greater than. So, greater than is this way, right? So our arrow has to be on the line pointing this way. A nice and simple graph, same as the positive numbers, just be careful of these two values here. I'm going to do one last example before we finish off, and this example is going to be a little bit different. Alright, so in this question we have -2 is smaller or equal to x, and x is smaller than 3, which means x has the value of anywhere between -2 and 3, including -2. So how do we graph that? So it's a little different than the singular inequality that we used to have without this -2 part, right? Because we just drew a single arrow and that was it. But this is very different because we have another value here restricting the x value even further. So let's just add the values in real quick. Okay, so as you can see here, this number line is a little bit rough because it's quite hard to draw digitally. But when you're drawing a number line, always use a ruler and a pencil, okay? So you have to draw number lines with a pencil. Alright, so how we start this question off is we do one inequality first, and then after we finish that, we can move on to the next. So let's do the blue one first, okay? So the blue one says that -2 is smaller or equal to x. So we have -2, and x is greater or equal to -2, right? So x must be greater, okay? And that's the blue one, done, right? Easy, no problem. And the green one is that x is smaller than 3, so we have 3, not including the 3. We are not allowed to include this 3 because there is no less or equal to sign here. So open circle and an arrow down, okay, since x is less than 3. So how do we incorporate these two graphs? We incorporate it by pretty much just combining them. So if we have a graph that goes this way, right, the green graph that goes that way, and the blue inequality goes this way, right, well, all we need to find is the common area, and the common area in which they both are the same is this bit, see, from here to there, okay? So how we draw this number line is we do a closed circle on 2, a line all the way up to 3, and an open circle on 3. So what we did there was we merged the two inequality graphs together, okay? Since the red bit is the common bit between the blue and the green. And so there you go. That's how you graph a simple inequality. Remember the rules that I have told you. When you multiply or divide both sides by a negative number, you have to switch the inequality sign, okay? And if, for example, you have x is greater than 2, you can switch it with 2 is smaller than x, okay? But remember, these signs do have to change because you're switching the order, right? So there you go. This is basic inequalities. So pretty much all the questions involving equations can be done with inequalities as well. So I'm gonna go over one more rule with you guys, and this rule is just an extra rule that you guys might find yourselves coming across. So we have x plus 2 over 3 is greater than 1 minus x over 4. Now, when we are solving this in an equation, right, we can easily do this by just cross multiplying, right? But in an inequality, cross multiplying can be extremely dangerous because there are two ways of ending up with an answer, okay? So there's two ways. We can move this x plus 2 down to the bottom of that fraction and move this down to the bottom of that fraction. Or we can do it the other way by moving the 4 up and moving the 3 up. So which way is actually correct? Well, I'll tell you, it's actually the second way. Why is it correct? Because when we are solving this, cross multiplying is multiplying each side of the inequality with this bottom number and this bottom number, right? So if we multiply both sides by 4, this side is going to be multiplied by 4, and this is going to get cancelled out. And we multiply both sides by 3, this is going to get cancelled out, and this is going to get multiplied by 3, right? Now, why don't we do the other way? Because if you look at this equation here, this is the correct way. But if we do it the other way, we end up with a different order of values. If we do it the other way, we'll end up with 3 multiplied by 1 minus x is greater than 4 multiplied by x plus 2. As you can see, these are actually different, right? And this is wrong. We never do this. We don't do this. It is wrong because, it's just a human convention. We think, cross multiplying doesn't matter what order, but it does in an inequality. It doesn't matter in an equation, but in an inequality, it really matters which order. So remember, we bring the denominators up to the numerator, the denominator up to the numerator instead of the other way around. All right, so that's the bonus tip here. This is the bonus tip. And good luck solving your inequality problems. I hope this has been enough to help you. And yeah, that's it.